Hi everyone, this is the third page of the Chapter 9 test review on logs and exponential functions. This one kicks off with these questions where it gives you an expression that's been simplified and then wants to know the name of the property used. And if you remember in class, I actually told you not to worry about that. Okay, so other teachers may have emphasized that differently. For my classes, I don't care so much that you know the names of the properties. Okay, what you should be able to do is look at these and make sure they make sense to you. You know, what did the person do to get from here to here? And is it allowed? Is it a property that we usually use? Okay. Is it true that log base anything of 1 would equal 0, for example? Okay. But other than that, I don't care about those ones. So let's look down at 33. 33 wants you to use the properties to put the logs back together again. We want to be able to write this as just a single log of some big quantity here. Okay, so the first thing to look for when you're doing one like this is any of these numbers out in front, they need to be put back on top like as exponents. Okay, so that 3 really belongs as an exponent on the y. And then, because this is subtraction with logs, that means the x and the y should be connected through division, okay, because subtraction of logs indicates division. I don't know why my background is so flashy right now. Sorry, just trying to adjust my light. Okay, so this would look like this. X divided by y to the third. Okay. So this next one, I'm going to do the exact same thing. I'm going to start by putting the 0.5 back up here as an exponent on the C. And then I'm going to put the A, the B, and the C together, and those are all addition, so that's going to indicate multiplication. So this would be log of A times B times C to the 0.5 power. Okay. Okay, 35. 35 and 36 are kind of going back to the exponential functions that we started out with, and this was kind of a long time ago because of spring break. So hopefully you can dust this off in your head. So exponential functions look like this. Y equals A times B to the power of X. And so A is the amount, your initial value, the amount you're starting with. And so in this case, that would be the 13,000. Okay. The B is your growth factor. Okay. And in this case, it's a depreciation factor. But here's what you need to be careful about. You need to be thinking about what would you multiply by to find the value the next year. And if you multiply by 0.15, which is what a lot of people want to do here, you're really finding like what money you're losing, what value you're losing. What is the 15% that's being lost? I don't care about what I'm losing. I care about what I'm keeping. So I need to do 100% minus that 15% to find what's left over. And then I can say B must equal 0.85. Okay. And then the 6 years, that's going to be my time, which usually goes up in the exponent. So I'm going to do this. I am going to do 13,000 times 0.85 to the power of 6. 13,000 0.85 to the power of 6. And I find out that it's 4,902, and this is money, so I'm going to go 94 cents. Now, that's a pretty steep drop from 13,000 down to less than 5,000. But to be honest, 15% depreciation is pretty steep. Okay, so you're losing quite a bit. However, I want to show you what would happen if you made the mistake of not doing this step right here. Okay, if you did that with a 0.15, which is a pretty common error that I see, look at that answer you would get. You would get that your $13,000 car is worth less than a quarter 6 years later, that it's worth about 15 cents. Okay, I hope that you would look at that answer and know that it doesn't make sense. Okay, and that would be the first thing I would check is, did you handle your B value correctly? Okay. Okay, 36 has got some math intimidation on it with all those words. Okay, but really what I would focus on is right here in the middle of the problem, you've got this equation, right, this formula. And it says L sub 0 is the intensity before entering the glass. Okay, and then T is representing probably the thickness. Yep. So the thickness is T, and L sub 0 is the intensity before entering the glass. So how thick must the glass be to block 10% of the light? Okay, so first off, notice that we're working in percentages. Okay, so if we're working in percentages, the intensity of the light before it's passed through any glass would be 100%. Okay, so I'm going to say L sub 0 is 100%. Okay, and I want to know, to block 10%, I want to know when will this be 90%. Okay, so I'm going to put a 0.90 here. And then this, the T, is what I'm solving for. I want to try to find the thickness. Okay? Okay, so I'm going to say 90%. I'm going to call this a 0.9 right here for the LT, because that's what I want to be left over at the end. Okay? And again, that's if I'm blocking 10% of the light, 90% would be making it through the glass. Okay? Let's see. Okay, so L sub 0 would be 100%, which in decimal land, 100% is really just a 1. Okay, which is going to make life a little easier here in a second. So we've got 1 times 10 to the power of negative 0.0022 T. I hope that I wrote that down correctly. Okay, to solve a problem like this, I'm going to have to use logs in just a second, but the first thing I would notice here is that 1, because it's a 1, it's not really going to matter. But if it was any other number, the first thing I would have to do right here is divide, okay, to get rid of that number in front. I'm not going to worry about that because it's just a 1 right here, but just so you know, if there were any other number, I would have to worry about it. And then I've got a variable up in the exponent, okay, and we've kind of already talked about this, that if you have a variable up in the exponent, we're going to deal with it by taking a log on each side. And the reason we're doing that is because now I can take this whole ugly exponent and put it down in front of the log 10. So let me write out what that's going to look like now. That's now going to say log of 0.9 equals negative 0.0022 T times log 10. Okay. I also want to point out log 10 is kind of unique because log of 10 is just equal to 1 because you're really saying 10 to the power of what makes 10. But I'm going to work through this as though you didn't know that, okay, because it might be something other than log 10. So really what I would do here is I would divide by this log over here. Okay, and so I'm going to put this thing in my calculator, log 0.9 divided by log 10. Oh, I didn't need this parenthesis. Okay, and I get negative 0.04. And you know what? I'm going to write that down shortened, but I'm going to keep that decimal in my calculator so I can use it later. So I guess I'm going to have to go down here. We just got negative 0.046. This is gone now, but I still have this parenthesis here. So negative 0.0022 T. And this is what I mean. So at this point, I would want to divide by that negative 0.0022. Okay. When I go to do this division, I'm not going to type in negative 0.046. I'm going to keep this decimal here, and I'm just going to say divided by negative 0.0022. That's going to give me a much more accurate answer. Okay? And I get 20.79. And does it tell me right around? It really doesn't. So I'm just going to put here, this goes all the way over here, but T equals, I'm going to go 20.8 centimeters. Okay, there's my final answer on that. So again, just to recap, I plugged the numbers into the formula where they needed to go. And then because my variable was up top in the exponent, I had to use logs to bring it down. Okay, one more ugly one. All right, the formula for pH gives the pH patient's blood. Okay, normal pH is 7.4. So the first one just wants me to rewrite basically this part of the expression using the rule about logs and division. Okay, so most of it's going to stay exactly the same. pH equals 6.1 plus, I'm just going to separate this. If it's a division here, this would become log B minus log C. Okay, this part right here is what it was really asking you for, is to take that thing and separate it with logs. Okay, so a sick patient has a bicarbonate concentration of 24, pH reading of 7.2. Find the concentration of carbonic acid. Ugh. Okay, so let's see. I just want to make sure. So B is the bicarbonate, so this is B. Okay, and then you've got your pH of 7.2, and then find the concentration of the carbonic acid. I might disagree with this just a little bit. I don't know that I would first solve the equation in part A for log C. Okay, I'm going to start by plugging my numbers in. Now you could do what that says, but I'm going to start by plugging my numbers in and moving everything and simplifying as much as I can, and then we'll deal with the log C. So I am plugging 7.2 in for my pH. And then I'm plugging 24 in for B. Okay, and then I'm leaving the log C alone. What I'm saying is that I can go ahead and calculate this piece. Okay, I can do 6.1 plus log 24. Okay, and I'm going to get something crazy. So this comes out to be 7.48 equals 7.2, minus log C. Now I would probably subtract that 7.48. And again, just for the sake of accuracy, I would do this part in my calculator and use the whole decimal. So when I'm trying to do this, 7.2 minus 7.48, let me move that up so you can see it better. I would type it in like this, 7.2 minus, and then I would use the answer function, which is on the negative key, this guy down here, okay, ANS. That'll bring down the whole decimal, and then I get negative 0.28. Let's see. And then that equals negative log C. So the next thing I would probably do here, because these things are both negative, I'm just going to get rid of those negative signs. And I'm allowed to do that because it's really like I'm dividing by -1. Okay, if it made you feel better, you could say I'm dividing by -1 and dividing by -1, and that's going to cancel and cancel. Okay, but really what I want now at this step is just this. 0.28 equals log C. Okay, and now this is a base 10, don't forget. I'm going to turn this thing around to exponential form. It's a little bit weird that the equal sign is over on this side. You're kind of going backwards from how you normally would go. But you could, if you wanted to, get rid of this 0.28 and put it over here, if that made you feel better. And then spin it around this way. So really what we're doing is 10 to the power of 0.28, and that's going to give us our answer for C. Okay, I'm going to go ahead and do that. 10 to the power of 0.28, and we get 1.91-ish. Okay, and that would be your your concentration of carbonic acid. Okay, that's your C value. Okay, so again, I don't know that you would need to start by solving for log C, but we did eventually have to get log C by itself to be able to solve the problem. Okay. Okay, one more page to go. I'm going to do one more short video to cover that, and you should be good to go.